Good day, my fellow students. I once again welcome you to the continuation of the parabola concept. Today we are looking at translated parabola. Initially, we were having these four orientations of parabola. We have the first one to be y squared equal to 4px. This was when the parabola is at the vectors to be 0, 0, when it is at the origin. Now, we are going to look at when the parabola has been shifted from the origin to a new vertex. In this case, the translation form of this parabola will look like this. So, this equation gives us when the parabola is open to the positive side of the x-axis. So in the translation form, we are going to get y minus k all squared equal to 4p x minus h. So this becomes the translation form of the parabola y squared equal to 4px. Now, we are going to look at some of the features of the translated parabola. So, we have to find the new vectors, the point where the parabola has been drawn from. So, we need to consider finding the vertex. And the vertex is giving us a coordinate h, k. So whenever we have equation of a parabola in the translated form, we will be able to find the vectors to be in the coordinate form h, k, where the h comes from the x expression and the k comes from the y expression. If we are bringing them on board, their sign need to be changed. If it is negative, it's going to be positive here. If it is positive, it's going to be negative here. So let us also look at how to find the focus. The expression for focus in the coordinate form when it is a translated parabola. So it depends on the orientation that we are dealing with. So if we are using this particular formula for the parabola, when it is open to the positive side of the x, then the focus is going to be h plus p, k. So if it is open to the y-axis, then it's going to be h, p plus k, or k plus p. So this is the expression for focus. Let's also look at the equation of a directrix. So the directrix will give us equation form, and according to the orientation that we have here, the parabola is open to the positive side of the x. So the directrix will be x equal to, and this will give you an expression h minus p. So if you have your h and your p, you just have to find the equation of the directrix. Also, you need to know the length of the latus rectum. Length of the latus rectum. So the length of the latus rectum is the length of the focus to the directrix, and it gives us an expression 4p. So this is the expression for the length of the latus rectum. Now let's have a sketch on the parabola, how it looks like. So we have a coordinate which is xy. We have our y here, or x, at the point of origin. Alright. This time our parabola is not taken from the point of origin. It is now having a new vertex. So we assume our new parabola will be found here. So we have here to be -3 against +2 on the y. So this will be our new vertex. So we need to show a plane, Cartesian plane at that side too, but let's use a dotted line. Alright, so this becomes our translated y, that is the y prime, and our translated x, that is the x prime. And our vertex is found here. So for you to get the focus or the p, you need to count the steps according to the value of the p to get your, so let's take the p or the focus to be at this side. So f, to our 2p, let's assume our 2p to be with 1, 2, 3, 1, 2, 3. So you close to form your box, and make sure when you draw the parabola, it sits on the vertex and the range of the parabola passes through these points. So this is the translated form of parabola, and the directrix will be found here according to the value of the p that we're going to get. And write the equation x equal to -p. So whenever you have been asked to translate any given parabola, all these informations are very important. And the translated form of the parabola depends on the orientation of the parabola. If you are dealing with different orientation, then you also have to use its right translated form. You need to find the vertex, the focus, and the directrix, and the length of the latus rectum. So from the focus here to the length of the directrix, that will give you the latus rectum. So from the focus to the vertex is 2p, and from the vertex to the directrix is also 2p. So if you move from focus to the directrix, then I'm going to get the 4p. We are going to use these concepts in our coming examples. Thank you for watching. See you next time.